Excuse me. Hi, everybody. My name is Gedanken. I'll tell you a little bit about myself and my background. I've been involved in digital video really since its commercial inception, about, oh God, close to 30 years ago. Starting with MPEG-1, worked up through MPEG-2 and MPEG-4, and now we're in HEVC. My focus has really always been on encoding, decoding, and transcoding, either for storage or transmission over a variety of networks, whether it's IP, cloud, satellite, terrestrial, pretty much any pipe. I've been very network agnostic. My background also includes system design, systems integration, installation. And I also have a background in pro audio and live video production. I worked for rock and roll bands back in the 70s and 80s, and I actually built a live projection system I took out in 82 with the very first Grass Valley 100 switcher. My hobbies include home improvements, working out, and amateur car racing. So today, I'm going to talk a little bit about MediaXL and its robust and broad product line, as well as some applications. Really, the focus is on the applications, not on the product line. MediaXL is no newcomer to digital video, and we're an industry leader in encoding, transcoding, and decoding. Our family of products are really flexible, high performance, cost effective, and of course they work, so they're very robust. We are a company that believes in that you should get the product that you want to your specific requirements, so our configurations are all custom. And please, if you have questions, feel free to ask while we're doing this. Just a little more of the company. Our actually U.S. headquarters, actually world headquarters, is Austin, Texas, and R&D and manufacturing is all in Seoul, Korea. And we have a worldwide network of partners and for support and service, as well as sales. So like I said, we've been around 22 years. The Hero product lines, what we call our products, have a really rapidly growing footprint. I've got close to 400 million multi-screen subscribers in a variety of different businesses, whether it's Fortune 500, broadcast, network broadcast, government, defense, and a lot of dealers and systems integrators as well. So what I'm going to introduce to you is a really cool application we developed as well as some of our products. Before I start that, I always like to give a little bit of background into video compression and transcoding, because I know there's a lot of confusion, and not everybody here is a video guy as well. So this, I think, will put things in context a little bit. But you hear a lot of terms, and obviously we're in an industry with lots of acronyms, but the two primary video compression schemes are MPEG-4, which is also known as H.264, MPEG-4 ABC. Technically, it's MPEG-4 Part 10 Advanced Video Coding. It's a block-oriented, motion-compensated based compression scheme, and it's really used a lot over the internet, local networks, and broadcast as well. A lot of satellite transmissions are MPEG-4. Most of your backhaul is MPEG-4. But more recently, there's a newer technology known as H.265, which is also called HEVC, or high efficiency video coding. And that's really emerged as a new standard. And what I'll do is, kind of give you some differences between 265 and its predecessor, 264. I apologize because I use all those different terms for each one interchangeably. So I may call it MPEG-4, I may call it 264. And same with HEVC and 265, and a lot of people do. So H.265, I said, is a video compression standard really designed for the newest technology and newest generations of high resolution video. It is a successor to MPEG-4 or H.264, but it does have a lot of improvements over what I guess it's kind of a now aging compression scheme. Just, all of them were developed by the Joint Collaborative Team on Video Coding, or JTC-VC. So they are international standards. And what's interesting is HEVC, the standard actually goes back up to 2010. So even though it's really just coming into use today in the last couple of years, it goes back 12 years now. So what's the difference? Well, 265 is massively improved, really, over 264. It roughly, I would say, doubles the compression. So if you're looking at it in perspective, a video with the same visual quality would take up about half as much space if it was a file, or half the bandwidth if you're streaming it. Alternatively, if you want to look at it, if you use the same bandwidth or the same file size, the quality would be better. So it's significantly more efficient. And part of this is because of how the scanning is done on the video. In MPEG-4, it's a 16 by 16 macro block. And in H.265, it's a 64 by 64 macro block, which they now call coding tree units or CTUs. I apologize, my computer's doing weird things right now. Give me 1 second, please. Okay, let's try this again. As my computer restarts itself. Give me 1 second, guys, sorry.
No problem.
There's a little power glitch here and my monitor went off.
And you're
So
in
Joy-
Austin.
Actually, I'm in Palm Springs right now. As soon as I can get this back up, I will. Okay. It looks like it should be back alive. Let's see if we can. Get back into PowerPoint. Slide.
Somebody must have just plugged in their car to charge.
Or something. I don't know what happened there. I apologize. Let me get right back here. I think I should be good now. Okay, I think it's back. Are you guys seeing that?
We are.
Looks
Okay.
good, Jay.
Okay, from current slide. Oh, I see what's wrong here. Sorry, I gotta stop this again. My bad. Okay, now we're back. Let me zip through these. Okay, sorry about that. Back where I started. You guys can still hear me?
Yep.
Okay, good. So as I was mentioning the macro blocks, if you look in this image, the right-hand side is H.265 or HEVC. And that you'll see there's different size macro blocks. In the areas that there's not a lot of information, they're very large macro blocks because you don't need a lot. And as it gets more detailed, you go to a smaller macro block. So that's one of the reasons it gets more efficient. Other areas on this, so I mentioned, the reduced file size. In addition to with the larger macro block size, HEVC also has better motion compensation and spatial prediction than MPEG-4 does. Now, on the downside, it means HEVC does require more computational horsepower to be able to press the data, but it's asymmetrical in that on the decompression side, it requires less bandwidth and processing power, which is why you can see it on things like smartphones and things like that. This really enables the streaming of 4K data over common network speeds. And one of the things, we should note is that while MPEG-4 does support 4K and even up to 8K ultra high def, it's really not efficient for most broadcast applications where HEVC or H.265 is very efficient for doing higher resolution and was designed with 4K and 8K involved. So, it really delivers you a better, higher quality video at the same bit rate as H.264, and it supports the higher resolutions. This is a little dated, but it just gives you some reference points. If you're looking at a 4K broadcast, in MPEG-4, it would require about 32 megabits. In HEVC, it's about 15 megabits. And actually, it's probably even less than that now with newer, as things have improved. Now, this does show, the average internet speed at 18 megabits. Sure, we all have, several hundred megabits or gigabit fiber coming into our homes, but the reality is a lot of that's shared bandwidth. So you're not necessarily getting that full bandwidth to each screen. I have 5 TVs in my house. I'm not getting, 200 megabits to each screen. So it's probably higher than 18, but it's certainly less than, whatever my bandwidth is. So, that's a little bit about MPEG and kind of the standard. So we'll talk a little bit about transcoding. Video transcoding, sometimes we refer to it as encoding, and it's a process where you convert a video stream or a file and you're changing something in it, whether it's the file format, it may be changing resolutions, bit rates, but you're changing something in it. And there's 3 elements that you're looking at in transcoding. There's the file format or the wrapper, whether how the transport's being done. The actual video itself will be the resolution and bit rate, as well as the audio. So, and it's really important because when a target device doesn't support their current format or has limited capacity, you need to reduce that file size or change something in order so it's viewable. So when you say, use the word transcoding, we're really talking about a combination of different things. And video conversion, it really is very computationally intensive. So transcoding usually requires more powerful computers, faster CPUs or GPUs, or a combination thereof. So as I mentioned, transcoding is kind of an umbrella term that covers three different tasks, really. You have transcoding, which, I would say, is taking already compressed or encoded video. You have to decompress it or decode it. And then you're going to alter it in some manner, whether it's changing the audio, changing the video, or changing the resolution, things like that. And then you're re-encoding it or recompressing it. Now, transrating specifically is involved with just the bit rate. So we're only changing the bit rate. We're lowering that bit rate or potentially raising the bit rate, which I don't know why you would do that really. So take a 4K stream, say at 13 megabits, and convert it to a lower bit rate stream. It's to 6 megabits. And then transizing is just simply changing the resolution. So sometimes, we use these terms interchangeably, but it's nice to know what they are. Now, what isn't transcoding? Well, there's also a term called transmuxing. And transmuxing really is just simply repackaging the stream to a different format. Maybe changing it from an MPEG transport stream to an OTT stream like HLS or Dash or Microsoft Smooth Streaming. So you're just transmuxing, but you're not changing anything else. And it's definitely a lighter weight application, doesn't require as much horsepower. but it's also important it's done quite often. So in transcoding, what do we do? So we're creating multiple video formats, and we're using that for things to maximize the quality of experience. When you look at companies like Netflix or Prime Video, which I would call, tier one users of transcoding, it allows them to optimize their video and their quality so their subscribers see the best quality video regardless of what the bandwidth coming into their device is or what their device is. Other reasons you would do it is repackage things to like Dash or HLS, and I'm not going to get into what all those different formats are, which allow dynamic switching. OTT lets you switch between resolutions. Your client device talks to the server and says, "Hey, this is how much bandwidth I have. Send me the best quality that I can get for that." We also use it for reducing storage. If you're someone that has a lot of content, a lot of movies, you'll sometimes transcode those to smaller file formats to save storage requirements. Other things you can do with transcoding is you can change your audio, add multi languages, change formats, add overlays, do clipping, trimming of the file. There's a lot of different things that you can do in transcoding, but the whole idea is to get the best quality and the best user experience. And as I mentioned, it's really vital for streaming. If we didn't have transcoding, you wouldn't be seeing, you wouldn't be able to cut the cord that a lot of people have done and watch all your television through a Roku stick or an Apple TV or a Fire Stick or even an Xbox or a smart TV. You really, those are all streamed over the internet. And those are internet I call a non-deterministic network. So we don't know what bandwidth we're getting. We talked about optimizing video quality and formats. So, now that I've kind of given you a little background on compression and transcoding, let's look at, what I really came to talk about, which is a cool application we developed. This application, it's a multi-camera synchronization over arbitrary delay. And we started this application with one of our customers in Korea, LGU Plus, which is one of the largest telcos there. They launched a 5G service and they wanted something, to entice customers to go to 5G, to use 5G. And they looked at a lot of different things, and a multi-camera service was something that really interested them. So, they wanted to expand their service landscape, and they really jumped on the project. In their application, they have multiple views of the content in their application. So if there's, let's say, 5 cameras, they'll see one large image and then 4 smaller ones, and the user's allowed to switch between those. So kind of the end user can switch their own show. Other applications of this would be sports events, baseball, basketball, football, other musical performance. I mean, if you think of baseball, the example I would use is you have a wide shot of the whole field, and then you have ISO cameras on each base. Now, the problem comes in is how do you sync the video from each of those cameras? If you're at the site in the production truck, they're all in sync because they're all coming from the same source. But if some of those signals go through other paths, like sending it back to the studio, or maybe they're using something, in some case, they're using a bonded cellular camera, which will have a lot of latency in it. They send it back to the studio for logo insertion, subtitling, captions, other video processing. You now have induced a delay into that. So when we say arbitrary delay, we don't know what the delay is necessarily, but we can deal with any of that delay. And what happens is if you have one camera delayed, it's now no longer in sync with the rest of the cameras. So obviously, a simple way to do this is simply add time code to each signal. In SDI, there's a standard called LTC or SMPTE12M, and most cameras can do it, as well as contribution encoders in the production vehicle can do it. And once we have that time code referenced for each signal to the camera encoders, all those paths are synced up. However, as I mentioned, if something is delayed, you then have to wait for the last signal to come. So you can synchronize purely on time code. Theoretically, you wouldn't have to buffer and wait for this, but due to other restrictions in downstream streamers and players, you really want those encoders synchronized. It's a working solution, but time code has to be available, and it's not always available. Surprisingly, there's a lot of cameras don't have time code capability. It's just a free running clock, so it's not synced to a central clock or a central time code generator. And the same thing with a lot of encoders. A lot of encoders can't sync to time code or even pass through time code. Some of them don't even generate time code. So, again, if it's not all synced, it's kind of useless. The media cell encoders, we support time code. We can pass it through, we can generate it, we can overlay it. The other thing is,
We're not hearing you, and we're hoping it's,
can you hear me now?
yes.
Sorry. All kinds of problems today. What I was saying is, sometimes time code is not always available. So another way was, if you can't do that, an idea was to overcome that by sending video with a time code overlay. So in other words, you overlay the video on top of some of the video. Our encoders can do it as a subtitle process, things like that. And then you do some OCR on that, because it doesn't have to be like an open caption. It could be closed caption. But to do that before the event, everything on the contribution encoders have to be switched to the time code generator output. Everything has to be processed. It's actually that calibration has to be done on site. The operators in a live event are pretty busy most of the time, so that's prone to human error. And even more so, if for some reason one of the channels restarts for whatever reason, all that calibrated information is lost. So that led us to come up with a robust solution that works all the time. And what we ended up doing, while I can't reveal the actual process because it is a trade secret right now, we effectively embedded the time code information into an unused sub audio track, and that tracks with the video in an MPEG stream. So or an SDI, that's always tracked with the video. So we embedded it. It's kind of hidden into the stream, but it's always there, and we can resynchronize everything. So in this case, you get the camera signal, you embed it, the signal goes back to the van, it goes into what we call our hero frame synchronizer, and it collects everything and resynchronizes it all at the last mile when you send out. Now, this doesn't have to be a live camera. It could be a other feed coming in. We're not limited to just a few seconds of delay. It can be a minute or 2 minutes or 5 minutes. It doesn't really matter. However, when you have long delays in one of those sources, everything's going to be delayed to that longest period of time. So this is just a slide that kind of shows some, a little block diagram. But if you look on the left, these particular devices had, 2.5 roughly milliseconds of 2.4 milliseconds, 2.4 seconds of delay. And once we resynchronize it, where the worst case was 4 milliseconds. So essentially your lip sync is spot on. But we had success on that. And I said, this is something we've done. These were some of the apps that LGU Plus was using. You can see the screen on, obviously this was in Korea. In the case of this was K-pop, the musical group, they have different fans for different performers in the group. So they all had isolated pictures, and people want to see different things. I said in baseball, you can select what you want to do. And I said it's a field proven solution. It's really cool, and it can work for a lot of different applications. It is patent pending. So we have deployed this. It is field proven. Does anyone have any questions on any of that? Anything I've talked about so far? No? All right, cool. Another cool technology I want to talk about a little bit is very low latency OTT, or over the top video. Inherent in OTT video is a lot of delay on just how the systems operate. Typically, you get around 10 to 15 seconds of latency or delay in the signal. And what happened was, several years ago, we started working with Akamai they wanted to reduce that delay. And we were able to achieve less than 3 seconds from our encoder, from the source to the encoder, through the internet to Akamai, to their systems, and back out to the player where someone's viewing it. So when I talk about delay, I'm talking about what I call glass to glass, camera lens to screen to viewing screen. And we were, I believe, the first vendor who commercialized ultra low latency delivery with Akamai. They gave us a certification, MSL4 platform cert. Well, things have come a little bit from that with some newer technology and using our embedded origin server that we can embed into our encoders or transcoders. We actually get that down to sub-second latency. So we're seeing total glass-to-glass latencies in OTT of less than 1 second, which lends itself to a lot of different applications in broadcast, for instance, in news gathering. Often you'll have a remote van. They use a lot of bonded cellular, which has a lot of delay. But using OTT, they can still go over the internet, over a Wi-Fi system, or over just even they can hotspot a phone and send it. And if they can get it down to less than 1 second, that's very, very usable. That's just another slide kind of showing it, how we do it. Now we do this both on SDI and on the MPEG transport stream. So we're not limited to just SDI signals. In this particular signal, it looks like we have about a second overall, because you have latency in the encoder and you have latency in the decoder. So that's kind of it on those applications. I'm gonna talk a little bit. I'll go through the stuff pretty quick here on some of our products, but we're a software-based platform. So any of our products can really be anything you want. They can be encoders, decoders, transcoders, or any combination of those. We also have both on-prem hardware, so physical devices at your location, or we can work in the cloud or on virtual machines. The cloud's kind of interesting because a lot of people think of the cloud as just this thing up in the air somewhere. It's the cloud. In reality, the cloud is a server farm. It's just not located at your facility typically. Where a virtual machine typically would be located at your facility. And we can do hybrids. A lot of people do on-prem, cloud, and virtual machine, depending upon their application. And our solutions, I said that we fit your needs and requirements, from single channel compact footprints to high density counts, as well as legacy codecs and interfaces. We do adaptive bitrate, multi-device transcoding, coding, flexible multi-screen video delivery. And I said we're network agnostic. We really don't care what the network is. I'm not going to go into the specs of a lot of this stuff, just because it can get, and I can certainly go offline with anybody on that. We call our product line the Hero 6000, and we've designated different configurations as live, file, event, contribution, intelligence, and management. We have a management system as well. But our standard server is a 1RU chassis with hot swappable power supplies, front panel, and GUI management on that, and lots of inputs and outputs. So we support 4K, 8K applications. As I mentioned, we're industry leading end-to-end latency. And different applications, whether it's satellite, land, terrestrial networks, OTT, ATSC 3.0 is another one. In fact, ATSC 3.0 was first rolled out in Korea. We were doing 8.3.0, probably about 5 years ago. With our new product, we call it the Hero version 5 engine. It's about 150% more efficient than our previous versions. So it's significantly more efficient. It was designed with 4K and 8K involved in that as well. And the power consumption is less. If you're familiar with transmission, a lot of people use SRT, which is an acronym for Secure Reliable Transport. It's a open standard for sending video over the internet reliably for error correction. I've seen a lot of people using SRT now for STL studio to transmitter links, even if they don't have dedicated fiber or they don't have microwave link, or they use it simply as a backup in case the microwave or something else fails. These are just different configurations. I think I mentioned that we do live. We also do files. We do combinations of that. Even in our live encoder, we can create files and then play them back out again. Just different things that the cloud, talked about. I'm kind of going through these quickly at this point. It's just, this one's pretty cool though. This is our Hero M, which is being released this year. It's a smaller footprint. It's about a 6-inch by 6-inch device. So you could put 2 of these, actually 3 of these side by side in a rack. Its main difference between this and our larger products is it's a single channel device rather than a multi-channel device. But it uses the same compression engines. It is a 4K HEVC encoder that supports multiple streams. All of our products do multi-stream output, whether it's HLS or Dash or whatever format you want. These are used in throwdown encoder, corporate meetings, webcasting, broadcast field contribution. You need something low latency from the field. It's a good way of doing that. Also monitoring and return fields. This is just some of the specs on it. It's 4K, 8 channels of audio. It's a very capable product. It's going to have a price point of under $5,000 as well. So it's going to be very, very cost effective. That's basically what I got for today. Any questions on anything?
Yeah, I do. Backing up to your multi-source synchronization, does that mean each source is going to have a box to encode its time sync signal there before it all comes back together again?
Yeah, typically what it would be used for is you'd have cameras that you're encoding the individual streams. And so because you're transporting them somewhere, a lot of it's used in remote production now, where they just have a say a CCU truck. They have a camera truck at the event. We see this a lot in collegiate and actually in high school significantly. Like in Texas, high school football is huge, so we see it there in collegiate football, other events. So yeah, it would require the encoders for each source. However, you could also synchronize an external source that was a stream that came in from externally. So in theory, yes, we could synchronize external sources with it as long as we can embed. We would have to transcode it though, because we need to be able to embed our time code, so to speak, in the transport. I didn't realize my camera was off. Sorry, guys. Anybody else? Anything else? I did put
I've got
my
a question. This is
Yeah.
Mark from San Francisco
Hey, Mark.
checking in.
We've spoken
Yeah.
before.
Some of us here, particularly when you see big RF cans behind Michael there, think that glass to glass means camera to tower beacon. So I just thought I'd
Oh, okay.
I'd
Well,
mention
when I say glass to glass, it's camera to playback device.
yeah, I
screen.
know that. I just wanted to make a pitch for the old timers here.
Okay.
When I was selling TV transmitters with Harris, we didn't talk about your computer screen at home. We talked about the tower top. I got a question for you. You mentioned Akamai. One of the real business pitches of ATSC3, which is yet to become viable, is that the internet, Akamai included, can't handle a massive Super Bowl type load. All right, therefore, you're going to jump on the data backbone of ATSC3, and that's why we're all going to go to ATSC3, because it's a much more efficient way to transmit to a whole lot of people. Akamai challenges that and has for years. What's your opinion?
I would challenge that as well, because the architecture of OTT is such that you're sending out multiple copies of the same stream. But people, because your client device is going to synchronize to that, it doesn't have to be exactly in time, because you're going to have buffering in your playback device. Now ATSC3 is actually an interesting thing, because it's to me the big part of next gen TV. Let's call it next gen rather than ATSC3. Is not necessarily terrestrial broadcasting, but is the internet aspect of it. It's a big chunk of it. Terrestrial certainly is important. It's going to help broadcasters get some revenue streams back again. with things like the data push and other things. But I would disagree that you can't broadcast events like the Super Bowl. Look, for instance, right now, is it Thursday Night Football? It's like at NFL is on Prime Video. They took over the contract from NBC,
Oh, I follow you.
and that's all over the top.
The one real reason to go to ATSC3 at your broadcast television site, at your TV station, is that you'll offer viewers more throughput than the internet alone can do, okay? And then, I mean, this is the old ATSC pitch. God bless everybody there. But bottom line is more and more things are going
Yeah,
internet only, okay? And it doesn't really
okay.
matter.
Yeah. Okay. I think I'm back. Yes, you would get more data throughput because of the combine between the broadcast as well as what you're getting over the internet. Because remember, 3.0 is not just to televisions; it's to handheld devices and other things as well.
Right. But
Also, it gives
talking
you-
about licensed broadcasters converting to ATSC3 as they've done in, what, about 50 markets now, as a reason to go to ATSC3. And one of the preachings of ATSC3 is you'll never be able to do internet only like Prime just can't do this. Okay, it's known it can't. And I've always had suspicion that it could all by itself, because the Thursday night Prime football, I don't believe has any ATSC transmission with it. Other than business-wise, I hear they let the local markets also do regular old-time TV. Anyway, just a comment as to, I understand it hands off and so forth, but does it really bring to the plate more data transmission to the point where people are going to invest in and ask to take their stations to ATSC3 only?
I don't know. I'm not sure how to answer that exactly. I mean, my understanding that it's kind of a mandate. At some point, you're going to have to be 3.0.
Well, there's no mandate at all right now. It's in front of the FCC if they're going to allow that. Now, what's going to happen to the ATSC1 viewers? So far they haven't allowed that.
Yeah, well, there's also issues right now. Can you buy a television that has an ATSC 3.0 tuner in it? As Hal mentioned. There's not a lot of them there.
That's only 10 to 15% of viewers. My TV set thinks its input is HDMI 1.
Yeah, I mean, I have a smart TV as well. So,
Yeah.
and 3.0 will work through smart TVs, but it's going to be essentially broadcast through the internet rather than terrestrially.
Right.
The other thing that 3.0 brings for broadcasters, I said, is the data push. I mean, auto companies are very, very interested in the fact that they can push out data to cars to update software in vehicles.
Tell me one that's doing that now, and how does Tesla get away without using ATSC3?
Oh, they're using cellular or satellite.
Really? Okay.
They use, well, that's what all the cars now, they use cellular networks.
Yeah.
But it's expensive. It's a lot more expensive to do it. And there's other
I
reasons.
just thought I'd ask some questions like that. I'm always intrigued as to what the real business of ATSC3 is going to be.
Yeah, I'm not a 3.0 expert by any stretch of the imagination. I have with other companies I've worked in that market, and we were selling solutions. But it is a better technology. I mean, one thing 3.0 gives you is better video and more channels.
No, I understand all that. I'm just talking, what's the business reason for it? It's got a lot of shiny things like 4K video and all that. But why are we going to invest in it? Ted Turner invested in satellite so he could sell more spots nationwide for his baseball team. There's a business solution, okay? And gee, that was back in the analog TV days.
True.
So I'm still looking for an app for ATSC3 where everybody's going to buy in. I thought maybe you were talking to it here. Anyway, thank you.
Yeah, I mean, that's a real good question, and I don't have a real good answer to it, frankly. But I think better minds than mine have come up with this, and there's a lot of applications that I think it will work with, but it's going to take some time. And it definitely takes time. Yeah, someone just mentioned that GM's OnStar system with cellular, and with lack of 3G coverage, it doesn't work anymore, or it's minimal. In fact, the original OnStar was analog. It wasn't even 3G. I had a system that was an analog. It wasn't even digital.
The original what?
I think the original OnStar system was analog.
Well,
It
I've
was-
only had OnStar since 2012, so I don't go back beyond.
Yeah,
that.
I had
I
a-
doubt it. It's
I
an
had a-
SMS. It's SMS text. I don't think that was ever analog.
We had OnStar, we had a 2004 Yukon, and you could actually talk to someone through it, but it was not a digital system. It was an
Well, yeah, you
analog.
push a button and you can have a telephone number and telephone voice through OnStar. I don't buy that. But the OnStar itself, I think, is SMS text. I think
Oh,
they
yeah,
had to
yeah.
move you to 4 now to get through. People have dropped 2 and 3 as far as the telephone cell system. The
Yeah,
different
I refer
functions.
to, yeah, I just refer to it all as OnStar, because we had a little button, there's a little help button you could push and get directions and stuff, and it was, when it was the first, 6 months or whatever it was for free, so we used it, and after that, I didn't subscribe to
Yeah.
it, because it was just, to me, it didn't give any value.
And I use mine all the time. I'll tell you about if your tires are full, your gas tank's full. In my case, what my battery is, I got a Chevy Volt. It's very, very useful. And they let you have it on a Volt for 5 years. So mine's only 3 years old now. So
Well,
that's really
I know-
nice to see. It'll send you a text that your battery's charged or somebody unplugged you. So it's really neat.
Yeah, there's other, if you're in an accident, they can unlock the vehicle. I know there's other things they can do.
Yeah.
I know BMW uses cellular for software downloads, because in Europe, some of the features in the vehicle are you pay for subscription based. Things like adaptive cruise control is subscription based. Even Apple CarPlay is subscription based in Europe. They tried it in the US and they got such pushback from the dealers and customers that they dropped it from a subscription basis and just made it non-subscription. But there's features in the vehicle they can enable remotely.
Sure.
I think automatic high beams, things like that. The sensors are there. And then if you want it, you pay X number of, I guess in Europe, euros.
Tesla just recalled 11 million cars on this window thing that would pinch people, and it was all over the air. Same with their battery sound. It's a federal mandate. The car's got to make noise. So
Yeah, that's get people to get run over.
Right. Yeah.
But
They
yeah,
do that. They do that all over the internet, and so far they haven't gone to Sinclair or any other huge broadcaster and said, "Hey, it's a lot cheaper to use your TV stations." Why haven't they done that yet?
Well, I think it's because it hasn't been fully implemented yet,
No,
and there's not enough out there. I mean,
Yeah.
yes, the major markets have a lighthouse or multiple stations up, but I think the coverage isn't there yet. And the same thing with the reception devices. They would have to put next gen receivers in the vehicles,
Yeah.
and that's just not there yet.
Right. Well, thank you. I don't want to turn this into an automobile discussion. That's what ATSC3, they just had the ATSC3 annual meeting in Detroit for this very reason, and they really pounded the drum on this. I've yet to see somebody sign up for it.
Yeah, probably a good site to look at is Pearl TV, which is kind of an ATSC, it's a consortium of people all around Next Gen TV. I don't know if they have information up on their website, but it's called Pearl TV.
I know
I'm
all
not sure if
about
it's
them, but
Pearl.tv.
ATSC.org would be the best.
Yeah, that's the other one.
Right. That's the main one.
Yep, that's true. That's the standard.
Well, thank you. I enjoyed
Oh, thanks.
everything
No,
from
that's-
glass to glass on.
Oh, yeah, I like that's some good conversation there. I did put in the chat my contact information. If anyone needs to reach me, if you want a copy of the presentation, ping me and I can send it out to you. It's not a problem. And certainly, if you have any need for encoders or decoders or transcoders, give us a call and let's have a shot at it.
Well, Jay, Eugene, thanks you very much. It was a nice presentation.
Oh, thanks. I've been to Eugene, by the way. I've been to the country fair.
There you go.
There you go. Now we're talking, now we're talking.
We got a couple of the organizers here.
Now, one of my wife's best friends actually has her father had a construction crane business and built a lot of the buildings at both schools, at Oregon State and U of O. And she's got a house out in Yachats, so my wife goes out there every year. They have a little girls' weekend out in Yachats.
Oh, very good. Yes, yes, yes. I was going to comment that one of the things that I had an 07, I still have GMC truck that I used before I retired was my vehicle, and OnStar, the cellular network connection, phone connection was my backup when I was out on remote hilltops and it couldn't reach my cell phone, but the antenna on the truck was just enough to be able to occasionally use it for calls. And one time I accidentally locked my keys in the truck and gave them a quick call, and boom, they unlocked the truck for me. So there was some good stuff with OnStar.
Yeah, a lot of I think other companies have it now. Subaru's got something similar. BMW does. You know, it wouldn't surprise me if most of the major manufacturers have some sort of remote systems that they can, do things to the cars. Because, they're all computers now.
And they just sunsetted it about 2 months ago on my truck. Anyway, again, thank you. Very interesting.
Oh, my
stuff.
pleasure. My pleasure, guys. Wish I could have been up there. Just timing didn't work out for me to travel this right now.
Well, we'll look forward to another time.
Absolutely. Absolutely. I see you got a couple ham guys here too. Got their call letters, call signs.
Well, there's at least 2 hams here. 3?
No.
Oh, yeah, two hams here in Eugene.
You
Yeah,
you got a ham here in San Francisco too.
I never went that far, but I had a friend who was WA3PKY. For some reason, this goes back 40 years, 50 years probably, and I remember his call sign.
Jay, most people taking ham license tests now are middle schoolers. You ought to look at it.
Yeah.
Don't they still require Morse code?
Oh, hey, you're 20 years out behind the times. That was deflated, and then I think in 2000 totally eliminated. Yeah.
That's too bad, really, because that's the one thing
No,
that
it's not. It caused a few fist fights, but I'm an extra light, which means a 5-word a minute extra. But now you can be an extra nothing. Yeah, they totally let Morse code go. Maybe more like 10 years ago.
Yeah, I mean, I date my, well, I first started in radio in 1971. I had my third phone license, and I was 14 and worked in a radio station in the DC area.
I did that in 1967. A lot of it. I bet you everybody's got a 1960 or 70 story here. You look like a young guy.
I could show you my Medicare card.
Me too. I bet you everybody on this call can show you your Medicare card.
What I don't understand, I just turned 65 in June, is, with this Medicare Advantage, and you go through it and I'm going, well, it's free. Why the hell isn't it just part of Medicare?
I'll tell you why. You want to know why? It's an HMO. They're gonna tell you what you can do. I've got friends that can't get glucose monitors. I got friends that can't get the operations they want because the Medicare Advantage plans are HMOs, and they are much more controlling than if you pay a little higher and have rural Medicare with your own docs. It's just like a PPO to an HMO. That's why. And they throw these freebies in trying to get you in. And matter of fact, there's been some lawsuits on misleading advertisements on that.
Oh, my Medicare
I've got a Blue
is a
Cross Blue
PPO.
Shield thing.
It's
a full part C.
Your Medicare Advantage?
Yeah,
Yeah,
Medicare Advantage is a PPO?
Mine's a PPO because I travel. An HMO would have been useless to me.
Yeah. Well, they manage it more like an HMO, even though they'll call it a PPO. I'd say the biggest one right here in the Bay Area is Kaiser. And there's all kinds of stories coming out.
Well, Kaiser's one of the original HMOs.
Right.
I mean, it's been an HMO for forever.
That's how they started. That's it.
But no, mine's Ascension Complete, which is a Texas-based one, but I could have gotten, there's a PPO through AARP. United Healthcare, I think Blue Cross Blue Shield has one as well that are PPOs. So it just made no sense to me. Then why, if there's no cost to it, why isn't all this included? Why do you have to go through different things?
'Cause they're
My only thought
managing
was
your
it's
healthcare.
insurance companies are getting paid from the government. They're getting paid the premiums,
Because
so they
they're-
make money on it.
They get your account and then they dispense with your medical attention, and it's usually substandard to if you're on your own. That's my answer.
Yeah, it could
You
be.
found
I
out
haven't,
otherwise.
haven't really had to use it, so that's
Yeah.
which is fortunate.
You know what amazes me is when you call Medicare on the phone, they answer the phone. That's a big outfit, you know? Very,
A government agency that actually answers the phone. What a
yes, they do.
concept.
Blows me away.
Does that say something about how many they have employed to answer the phone?
Well, that's not like the federal government, is it?
So Sinclair is technically your AT&T.
I was going to make another comment here to Hal. I did it on the notes too. Everybody moved off of 3G onto 4G and now 5G. That didn't obsolete OnStar whatsoever. So, and you know, the brand new Chevys have OnStar. You know, there's a cell phone you can buy, and also then there's the SMS for the data. And
Had
they're
a
all on-
friend
all
who
on
used to
new,
sell
new
General
platforms.
Motors products. His big complaint was when they moved from one band to the other, they didn't offer upgrades. And there really wasn't a way to unobsolete the car. If it was set for 2G or 3G, you could not move to 4G or 5G. Now, if
That's
that's
because of the radio.
that's
in the car.
incorrect, that's, maybe they've changed things now.
Yeah, it's,
Well, I don't have a 20-year-old car, so I don't know about that.
well, my 07
This is Arizona. If you lived here, you would.
was analog, so.
No, I guess I think in 2007, everything was analog, even TV and radio, huh?
No, not quite. They'd made some of the digital transition, but there were certainly a lot of analog around. All designed because it started in my 07 truck was the last of a series that started in the 98.
Yeah, back then there wasn't really digital cellular.
Yeah.
I think that's what the obsolescence was the analog systems.
Yes. Yeah.
But I did remember just reading something about that, with lack of 3G service that there were issues with it. So maybe they had, I don't know.
Well, same with your flip phone. Sooner or later, they're going to turn it off. How about that big brick phone? Those were all analog.
Oh, I had one of
They
those.
got turned off too.
That was a good phone. Could always use it as a weapon if you had to too. I think they were what half a watt output or something on them.
Well, I think the new ones are that too. They're limited.
If I remember it was issues with, people were concerned about the RF because you're holding this antenna right by your brain.
Yeah, that's why there are limits on cell phones. I think it's like a 1/10 of a watt or something.
Yeah, but the old Motorola
Yeah.
bricks were very high output. I mean, now they're handheld computers. I still say the best cell phone was Nokia 6190.
What about us hams that hold a handy talkie with 5 watts there?
Yeah, don't do that.
Yeah.
Don't do that. Use a speaker mic.
But then look at it this way, you've survived this long.
And I had my handy talkie cell phone, if you will. Well, not really cell phone, clear back from the late 70s. We had our auto patches up.
Did that come with a helmet with a propeller on it?
And a tinfoil hat.
You do know there's 2 ATS3 stations.
I think we've learned a lot about RF emissions and stuff. Plus, the FCC just reinstituted certification needed to make sure you're not harming anyone, including yourself. So you ought to pay attention to that. But it's not only what frequency and power you're on, but it's the amount of time. It's just like in the microwave oven. Popcorn pops for 3 minutes. It doesn't pop for 3 seconds.
Yeah. Well, then also think about all the Wi-Fi, which is all microwave.
Yeah. Well,
You know,
there are
that's-
emission masks, that's up quite a higher frequency. It doesn't affect us as much. What really affects us is around 3 meters. You know where the 3 meter band is? Come on, guys. FM broadcast. 100 megahertz is 3 meters.
This 3 meters is the
150 megahertz is 2 meters. Ever hear of the 2 meter handband?
Yes. And the aircraft is between the two.
What year did the FCC sell off 700? That 2008?
Well, they've been selling it off forever, plus the repack this last couple of years. So.
Worked for a company that at that point in time that sold, wireless mics and such to, churches and things like that. We had to dump all our 700 meg stuff. So I'm just trying to remember. I know it was before 2000. Somebody brought up the analog digital conversion thing. So I was trying to remember when.
Yeah, the first one to trim you down to channel 53 was in the 2000s. I know at Georgia Public, we went to the very end and got off it in 2009. That was because of dollar problems with the state. But they sold everything up from channel 53 at that time, got sold. And of course, TV used to go to channel 69 up around 890 megahertz. There's been all
83.
kinds of peelbacks about that.
Yeah,
It went to 83.
channel 83. So, and I've seen stuff on channel 83, usually a booster.
Yeah,
Channel 69 was just for all the frat boys.
yeah, that's all gone now. What is it? Goes up now to channel 35? The repack? Or 36?
One of those is supposed to be a blank.
Some people say there's more coming, I have a theory, guys. I'm a businessman as well as an engineer. And my theory is if there wasn't the federal must carry rules, half the TV stations that are on the air today, and all of them that got auctioned off would have been gone because there's no business forum without must carry on cable and satellite. There's some, Home Shopping, Trinity, God bless all those guys, but they're all there for must carry.
Well, think of this, this is what happens.
In my humble opinion.
Licensees for the PMT. Right, so they have 2 employees.
Yeah, I think all the analog translators and high frequencies are all gone now, I think.
Transmitter, all the translators, right? And the way it works is.
Yeah, nothing above
they
35, right?
Local management. Because they allow.
So Jay, can you wrap it up?
yeah. I mean, I'm just hanging. I can leave the link open if everyone wants to chat. If not, it's been real fun, guys.
Well, thank you very much for Portland.
Yeah.
Oh, my pleasure. Thanks for having me. It's some good discussions there.
Thanks again from Eugene, and we'll see you guys all later.
Thanks from down in Tucson.
So real quick, Jay, you say we've talked before? Do I know you?
Yeah, we have. We've come across. I just actually was thinking we're on LinkedIn together, so I know we've
Okay.
crossed our paths. And
Hey, I'm here recruiting. I'm the program guy for San Francisco Chapter 40. We might try to get you to do this for us after the first of the year.
yeah, let me know. I'll be happy to.
All right, great.
Actually, hopefully I can travel up there even for that.
Yeah, where are you at?
Well, I live in Austin now. I moved from San Diego to Austin about 1.5 years ago.
Okay.
Right now, I'm currently in the Palm Springs area because I have a place in Palm Springs. We do seasonal rentals on, so I'm out here
Yeah.
for October. But I've done it when I was with, I think, Cencor. I did the San Francisco SBE. You guys were down by, it was a little restaurant down by the waterfront.
Yeah, they tore that down, made a ferry building out of it, but we're still close to the ferry building there on Embarcadero with the restaurant.
Yeah, no, I like San Francisco.
If you ever come back to Oregon Country Fair, stop by the main stage front, have a party, say hi. Okay.
I'd like to make it again. It was certainly something to be experienced. We jokingly say, because my oldest son is quite different than my wife and I and my younger son, and he went to Humboldt State, and one of his college roommates was very, very conservative, and we always joke and said, had Stephen gone to the country fair, his head would have exploded. Like scanners. it just went poof, because you wouldn't have been able to deal with it. But it was a lot of fun. I mean, it was certainly an experience. I like that, you know.
You're
It's
talking
just,
to Country Fair. This gentleman right here runs the radio station.
I'm going to bail, guys. Thank you.
okay. All right, gentlemen, it's been an absolute pleasure. And ladies, I guess there's some ladies there as well.
Thanks from Seattle. Good program. We'll get to see you. Bye all.
Thank
you. All right, take care, everyone. All right, bye-bye.